Hello everyone, let me correct these test 2 review. So the key for these problems, so I will go slowly, step by steps. Let us do the first one. We compute the partial derivative with respect to x, to y, and fxy, yeah, etc. So let us do the first one first. Question A. In order to find the partial derivative with respect to x, or we can write it in this way, partial of this, and we're given that f of x, y is 5x cubed square root of 2y here plus e to the x squared plus y cubed. Okay, that's it. Again, partial derivative with respect to x, then we treat y as a constant. So, therefore, this becomes partial derivative of this guy. These are only the variables here. So, therefore, the differentiation of a sum will be the sum of differentiation. And the constant we can take out of the derivative. Therefore, it will be 5, let me just write it slowly, d over dx of 5, let us write it this way, x cubed plus d over dx of this guy, e to the x squared plus y cubed here. Okay, then this guy, they are constants, so we can take out of the differentiation. And here we apply the chain rule. Okay, therefore it becomes 5 square root of 2. We can separate it into these forms. Okay, d over dx of x cubed. Okay, this here, the chain rule tells us that, okay, the chain rule, e to the u prime here, it will be u prime e to the u, right? U in our case will be x squared plus y cubed. Therefore, it is partial derivative with respect to x of this guy times e to x squared here plus y cubed. Okay, nothing hard. Then this guy, derivative of x cubed, what is it? That's right. It is 3x squared. You're right. And here, partial derivative of a sum here, and y cubed, we treat it as a constant. So it will be derivative of x squared, right? Which give us 2x. And derivative of y cubed here give us 0, so it disappear. And multiply with here this guy, which is e to the x squared plus y cubed. Okay, that's it. Or you can simplify further. 5 times 3 would be 15, square root of 2. And here you can write it as x squared, square root of y, plus 2x e to the x squared plus y cubed, right? That's it. That is the question A. Then let us do the question B, which we need to find fy here, or partial derivative with respect to the y. And the similar story here, right? Derivative of this guy is here. Now in this case, derivative here, so y is a variable in this case. And therefore, partial derivative of this, it will be, again, 5, we treat 5x cubed is a constant, right? Let us write it as 5x cubed. This is d over dy of square root of 2y here, or it is square root of 2 times square root of y. Okay, if we write it this way, we can avoid the mistake here with the coefficient 2. The same story. Here, partial derivative of e to the x squared plus y cubed here. Okay. Therefore, this one, again, this is a constant. We can take it out. And derivative of square root of 2y, what is it? Correct. It is this guy, right? Or you can do it slowly. Here, y, square root of y, you can write it as y to the 1/2, right? Derivative of this guy, it would be y to the 1/2 subtract, what is it? 1 here, right? And we multiply with the power of this, which is 1/2, or it is 1/2 times y to the negative 1/2, or you can write it 1/2 times 1 over y to the 1/2, or it is 1/2 here times 1 over square root of y, or this is a product of two fractions. You can write it as 1 over 2 square root of y, right? Anyway, this form is correct. So let us continue. Plus here, again, we apply the chain rule, which is d over dy of x squared plus y cubed here times, correct, e to the x squared plus y cubed here. Okay, so the side computation here, let us remove it. So we can simplify it. Here, square root of 2, it will be 5 square root of 2 divided by 2 times x cubed divided by square root of y here. And this guy, derivative with respect to y, then x squared derivative of this would be 0. Derivative of y cubed with respect to y give us, yes, 3y squared, e to the x squared plus y cubed here. Yes, that's it. So we're done with the second problems here. Okay, double check it yourself. And let us continue. fxy, okay? See fxy, it means we take derivative with respect to x first, and then take derivative with respect to y, okay? Previously, it means we need to take partial derivative with respect to y of df over dx, which is the result in the part A, right? Let us copy it here and paste here. Okay. Again, partial derivative of this guy with respect to y, okay? and we treat these guys, the others, as constant, which means this will be 15 square root of 2 x squared d over dy of, let us write y to the 1/2 here, right, which is square root of y, plus partial derivative with respect to y of 2x here, e to the x squared plus y cubed, okay? And again, if we take partial derivative with respect to y, then 2x is simply a constant. So in other words, we can write it this way. Okay, same things. So now it will be 15 square root of 2 x squared, partial derivative of square root of y, same story. It will be 1 divided by 2 square root of y, and double check it yourself. Here, again, we use chain rule, which will be partial derivative with respect to y of x squared plus y cubed e to the x squared plus y cubed here, right? Okay, let us simplify it. Here, it will be 15 square root of 2 over 2 x squared divided by square root of y, okay? Because x squared is a whole number times 1 over square root of y is the same as this one, okay? Plus 2x here, partial derivative of this with respect to y, so it will be 3y squared e to the x squared plus y cubed here, right? We can simplify it, which will be 15 square root of 2 divided by 2 x squared divided by square root of y here, and 2 times 3 would be 6 x y squared e to the x squared plus y cubed. Okay, that is the question B.